Hi everyone, and welcome back to Educator.com. In this mini lesson, we're going to do page 1 of the A+ Physics worksheet on work and power, and you can find that worksheet from the link down below the video. With that, let's dive right in. Problem 1. The work done in accelerating an object along a frictionless horizontal surface is equal to a change in the object's, well, this is just the work energy theorem. The work done is equal to the change in the object's kinetic energy. Number 2, the graph below represents the relationship between the work done by a student running up a flight of stairs and the time of ascent. What does the slope represent? Well, slope is rise over run, and that's going to be in terms of work and time. And work divided by time, as you recall, is power. So that's going to be the power output of this student. Number 3. A student does 60 joules of work pushing a 3-kilogram box up the full length of a ramp that is 5 meters long. What is the magnitude of the force applied to the box to do this work? Well, work is going to be force applied times the distance over which it's applied. So, if we're looking for the force, that's going to be the work divided by the displacement. The work done was 60 joules. The displacement was 5 meters, therefore our force must be 12 newtons. Answer number 3. Looking at number 4, we have a boat weighing 900 newtons and it requires a horizontal force of 600 newtons to move it across the water at 15 meters per second. The boat's engine must provide energy at the rate of, well, the rate of energy is provided at, that's power. And power can be solved for using force times velocity. Our applied force is 600 newtons. Our velocity is 15 meters per second. So that's going to be 600 times 15, or 9,000 watts, which is 9 times 10 to the third watts. Answer number 4. On to number 5. A motor used 120 watts of power to raise a 15 newton object, so the force required was 15 newtons in a time of 5 seconds. Through what vertical distance was the object raised? Well, a couple different ways we could do that here. If power is force times velocity, and velocity in this case is just going to be displacement over time, that'll be force times our displacement divided by t. And we want to solve for the displacement delta y, so I would say delta y is power times time divided by force, which is going to be 120 watts times our time of 5 seconds divided by our force of 15 newtons. So that's going to be 600 divided by 15, or 40 meters. Answer number 3. Number 6. The diagram below shows points A, B, and C at or near Earth's surface. As a mass is moved from A to B, 100 joules of work are done against gravity. What is the amount of work done against gravity as an identical mass is moved from A to C? Well, as we move from A to C, remember, gravity is a conservative force. It's independent of the path. So the work done against gravity is going to have to be the same thing because C is at the same height as B. So correct answer, number 1, 100 joules. Number 7, 1 watt is equivalent to 1. Well, a watt is a unit of power, which is work divided by time, and units of work are joules per second. So a joule per second is 1 watt. Number 8. 2 weightlifters, one 1.5 meters tall and one 2 meters tall, raise identical 50-kilogram masses above their heads. Compared to the work done by the weightlifter who is 1.5 meters tall, the work done by the weightlifter who is 2 meters tall is, well, that must be greater. The weightlifter who's 2 meters tall lifts the mass further, does work over a greater distance. In that case, you're going to have more work done. One last problem here. A 40-kilogram student runs up a staircase to a floor that is 5 meters higher than her starting point in 7 seconds. The student's power output is, Well, power is going to be work divided by time. But work is force times displacement divided by time. In this case, the force that the student must overcome is the own weight of the student. So that's going to be mass times acceleration due to gravity times displacement divided by time. Therefore, power is going to be mass, 40 kilograms, acceleration due to gravity, 9.8 meters per second squared, change in position, well, 5 meters, in a time of 7 seconds. So when I put all that together, 40 times 9.8 times 5 divided by 7, I get 280 watts. Answer 2. All right, if those went well, terrific. You're ready to move on to the AP level questions. And if it didn't go so well, now would be a great time to go back and review the unit, the lesson on work and power. Thanks so much for your time, everyone, and make it a great day.